In recent years, artificial intelligence (AI) has tremendous impact on the technologies of robotics, pathfinding, and problem solving. Searching is an integral part of AI, and AI machines use it along with the various searching algorithm techniques to systematically explore alternatives and find the most suitable path to reach the goal. Because of this only, it is possible to use AI in various applications. I welcome you to your channel Ullas Kumar Gokhale for learning. Today we are going to learn searching in artificial intelligence. Let us start with the agenda. First, we'll have the introduction to searching. Then we'll discuss the searching for solutions. Already we have discussed the part of formulating the problems. Here we are searching for the solution. Then the next will be the search requirements, and then we'll go for the steps in searching process. Then we'll discuss the searching process, and then we'll discuss the basic search algorithm, which will be a general algorithm. Then we'll see the key issues in the search algorithm, and after that we'll see the how we are going to evaluate different search strategies, and lastly we'll see the different search strategies. So let us start with the introduction. In recent years, artificial intelligence has a tremendous impact on the technologies of robotics, pathfinding, and problem. Artificial intelligence is being used in this application, and humans are dependent on these technologies to find the solution and perform tasks. There are so many examples of use of AI. So we'll not discuss that here. However, what makes these actions possible? Here, this is possible because of the search algorithm. And what is searching? Searching is an integral part of artificial intelligence, and AI machines use it along with various search algorithm techniques, that is BFS, DFS, etc., to systematically explore alternatives and find the most suitable path to reach the goal. So here we'll be discussing the general searching in this. Now first, searching for solutions. Now a solution is an action sequence. So search algorithms work by considering various possible action sequences. So once the problem is formulated, then we have to search for the solution. So search solution is nothing but a action sequence. Then the possible action sequence starting at the initial state form a search tree with the initial state at the root. So the search tree will have the initial state at the root, and then branches are actions, and the node correspond to states in the state space of the problem. So here the nodes will correspond to the states, and then we need to consider taking various actions. So we do this by expanding the current state. So the current state will be expanded, and here we'll make use of the actions to expand the current state. So after expanding the current state, we'll get new states. So here you can see in the figure, we have the initial state, and after expanding, we'll have new states. So here A is the initial state, B and C, these are the new states. Then after that, we'll expand the new states, that is B and C. So again, we'll get the new states, maybe D and E. So in this way, the searching will go on. Then searching through a state space involves following requirements. So first requirement is a state of state. So here the states are reachable from initial state by sequence of action, as well as details like where the search begins, ends, and then the transition model, etc. So the search should have a state of state. Then the second requirement is operators and their cost. So this will help us to find the most optimal solution with the lowest cost, because every path the cost will be defined. Then next is the initial state. So information about the state where the agent first starts the search, that is nothing but the initial state. Then we need a test to check for the goal state. So whenever we want to end the search, we'll have to check whether we have reached the goal state or. So for that we need a test to check for the goal state. So these are some of the requirements of the search. Then the searching process steps. Here, the generic search process can be very simply described in terms of the following steps. The first step is here, do until a solution is found or the state space is exhausted. So we have two alternatives. We have to continue our search till we get the solution or till the state space is exhausted. So if the state space gets exhausted, there is no solution. So the first step is we have to check the current state, and then second step is execute allowable actions to find the successor state. So that is nothing but the expanding the state. So we'll expand the state to get the new state. So third step is pick one of the new states and again check if the new state is a solution state. If it is a solution state, then we'll have to end that. Otherwise, if it is not, the new state becomes the current state and the process is repeated. So here the searching process will have these steps and it will be iterative till we get the solution for the problem. Then let us go to the discussion on. Now we need to denote the states that we have generated. So we call these as the nodes. And the data structure for node will keep the track of not only the state but also the parent state and the operator that was applied to get the state. So from the parent state we get the child state. So the node will keep the track of this. Then in addition to the search algorithm, we have list of nodes which is called as the open list or fringe. So this fringe will keep the track of nodes that have been generated but not yet explored. So they will be part of the fringe. Then the fringe represents the frontier of the search tree generated. So it represents the frontier. Then initially the fringe contains a single node corresponding to the start state. So as we take example, it will be clear to you when we take the example with the particular search algorithm. So it will have a single node that will correspond to the start. As we have seen earlier, A was the initial state. Then the algorithm always picks the first node from the fringe for expansion. So first node will be picked for the expansion. If the node contains a goal state, the path to the goal is returned. So the search will be over here. Then path corresponds to a goal node can be found by the following parent pointers. So otherwise, all the success nodes are generated and they are added to the fringe. So one by one, we'll generate the successor nodes and add to the fringe. The successor of the current expanded node are put in the fringe. So we'll soon see that the order in which the successors are put in the fringe will determine the property of the search algorithm. So here we have to understand this. This will depend on the search algorithm. So we have breadth first or we have the depth first algorithm. So depending on that, the order in which the successors are put in the fringe, that will be determined on the search algorithm. Then the basic search algorithm will have, say we take L as the fringe. So let L be the list containing the initial state. Then loop if L is empty, return failure. So if L is empty, return failure. So that means we are not getting any solution. Then here we select node from the fringe for expand. Then if the node is a goal node, then we return the node, the path from the initial state to the node. So that will be the solution. Else generate all successor of the node and merge the new generated states into L. So that will be put into the fringe. New successor nodes, they will put in one by one into the fringe. And lastly, we end the loop. This is the basic search algorithm. So that will be taken, and we'll discuss the different algorithms with the help of this. Then what are the different issues in the search algorithm? So firstly, the search tree may be unbounded. This may happen if the state space is infinite. So if the state space is infinite, then we cannot terminate the search. And it can also happen that there are loops in the search space. So if there are loops, then we'll not come out of the loop. So how can we handle this loop? This is the first issue. Then corresponding to search algorithm, should we return a path or a node? So here this depends on the problem. For example, in case of n queens problem, we are only interested in the goal state, whereas in problems like 15 puzzle, we are interested in the solution path. So that's why this will depend on the problem. And then last issue is, here the objective of search problem is to find the path from initial state to the goal state. So if there are several paths, now which path should we choose? Our objective could be to find any path, or we may need to find the shortest path or the least cost. That is nothing but the optimal path. So we have to consider these key issues in the search algorithm. Then how to evaluate the search strategy. So we'll look at various search strategies and evaluate their problem solving performance. So we'll have to make use of these three factors. First is completeness. So is the strategy guaranteed to find a solution if one exists? So that means here the strategy should guarantee that we'll get a solution if there is a solution. That is completeness. Then secondly, we have the optimality. Does the solution have low cost or the minimal? Whether whatever solution we are finding, it is having the minimum cost. That is important. And then third is, what is the search cost associated with time and memory required to find the solution? So time and memory, these are the two requirements. So we'll have the time complexity, that is nothing but the time taken, that is number of nodes expanded, or maybe we have the worst case or the average case to find a solution. So if we are expanding more number of nodes, then it will take more time. Then the last is space complexity. So space used by the algorithm, so this will be measured in terms of the maximum size of the fringe, because every time we are putting the current node into the fringe for expansion, so the space required for the search algorithm will depend on that. So these are some of the evaluating criteria for the search strategies. Then last, we are coming to the end, that is, we'll just have what are the different search strategies. So we'll consider the following strategies. First is uninformed search or blind search. So in this, we'll have the depth first search, DFS, then breadth first search, BFS, and then depth limited search, then iterative deepening search, bidirectional search, then uniform cost search. So these are the different types of uninformed search, which we'll discuss in the next video. Then we have the informed search, and then constraint satisfaction search, and adversarial search. So these are the different search strategies. So we'll discuss some of them in the next video. So with this, we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, or mail, or Instagram. Then if you like the video, press the like button, share with your friends, and subscribe to channel Ullas Kumar Gokhale. And don't forget to press the bell icon so that you get new videos on this topic, artificial intelligence. And thanks for watching. Have a nice day.